Hi there. This video series is to display my problem solving and learning abilities. I plan to show that I can solve any programming problem, regardless of whether I already have expertise in a particular language. I hope this helps others in my field to learn not just how to solve a particular problem, but how to teach themselves a solution to an unfamiliar problem. Currently, I am learning Python. I have no professional experience in the language and have only been learning it since mid-January. My only formal training is completing the Python for Programmers course on Execute Program. While I'm picking Python up fairly quickly, I cannot claim any real expertise. Today, I'm showing my approach to solving the 32nd Project Euler problem from start to finish, vocalizing my thought process throughout. As always, I will link to Project Euler and my repository in the description. Let's dive in. Problem 32 is Pandigital products. We shall say that an n-digit number is pandigital if it makes use of all of the digits 1 to n exactly once. For example, the 5-digit number 15234 is 1 through 5 pandigital. The product 7254 is unusual, as the identity 39 by 186 equals 7254 containing multiplicand, multiplier, and product is 1 through 9 pandigital. So we've got like 1, 2, 3, 4, 5, 6, 7, 8, 9. Find the sum of all products whose multiplicand multiplier product identity can be written as a 1 through 9 pandigital. Hint, some products can be obtained in more than one way, so be sure to only include it once in your sum. Okay, so if we think about this a little bit, let's go ahead and do a little bit of maths here. So 99 times 99 is 9801, which means that two-digit numbers are not going to get us to a 4-digit number. Oh, but we could have like a 1 times... Well, a 1 times something would always be itself, but there might be like a 2 times something. But in any case, we are very likely going to only want like... a 2 and a 3-digit number multiplied together to get a 4-digit number. But now that I'm thinking about this, it might be more than that. So, like, there might be 2 times something that gives us, like, a 2 times a 4-digit number that gives us another 4-digit number that, those 9 digits happen to be pandigital. So, let's see. So our first number... Alright, let's go ahead and... copy over our problem statement so that we can get started here. Of course, we're going to do our normal copy these 2 lines. Okay, so I think that the general strategy I want to use is... So this is find the sum of all products, but unique products. So, a couple problems ago, we had the same thing where we wanted to have a unique, and the easiest way to do that I am aware of right now in Python is to have a dictionary. So, let's have a dictionary called products, and we will expand on that, and then print some of the keys And then so for, say, I in range 2 through I'm actually going to go ahead and make this 10,000. And then for J in range 2, 10,000. P equals I times J. I don't need a semicolon. This is not Java. And then what I'm going to do is have let's see, what's a good name? I'm going to make a string that is those 3 things combined. So I'm just going to say string P equals string P actually I'm just going to call it digits. And then we'll say if length of digits equals 9, then let's see, what do we got here? Digits dot I don't think that'll work. If length of digits is 9. Basically, we want to know if digits has, like, all these digits. And 1 digits and 2 digits. So there's probably a better way to do this for K in range 1 to 10 because the range is exclusive. Let's see, is 10,000 really enough? Well, let's operate under the current assumptions. And say if K in digits okay, actually, if not string K in digits, let's see. So we'll want a boolean here, and let's say add equals true. And if we find any digit that isn't in our string, we will set add equal to false. And then if add products digits equals, and I'm just going to default it to 0. Okay, so that actually should give us the correct answer. So let's find out. I cannot see through my cat. Okay, there we go. Okay, so this is actually taking quite a long time, which kind of makes sense because we're asking it to do a ton of equations here. But I think that this is more or less the correct approach. I might be operating under too many or too few assumptions. Like, for instance, 2 times 2 is not going to create a product with a 9-digit number. It just won't. Or it would have to be a 7-digit number. So this might take a little bit more time to run than we want it to. Okay, maybe not. Object is not iterable. Oh. Well, you have to call it as a function if you want to use it as a function, huh? Okay, let's try this again. And I do think we're taking a little bit too long here. Like, this is taking a little bit more than a minute. But based on the fact that we failed out at line 20 within a minute and a half, let's just see how quickly it runs. I think that I am definitely cycling through more things than I need to. So, there's definitely a way to do this more precisely. Okay, right now my cat is sitting on top of my computer tower and chattering out the window. So that's entertaining. And let's see, has it been a whole minute yet? Okay, so that does take just slightly more than the suggested 1 minute limit. Like 1 second, 1.5 seconds more. So obviously there's a way to do this slightly better, but what I first want to do is see if this answer is correct, because if this answer is correct, then we can optimize a tiny bit, but okay, so that's not the correct answer, so we know that okay, so we're obviously missing something. And what I want to do, actually, is just go ahead and print products real quick. Now, obviously, this is going to take another whole minute, plus a tiny bit to run. So we'll just kind of have to give it that time. And let me talk through what I'm doing here. So basically, all I'm doing is I'm saying, okay, we need two numbers to multiply together, so we are assuming that those products are going to be within this range, or those numbers are going to be within this range. So just look at all combinations of all numbers in that range. And I would say there's definitely a better way to do this, either by narrowing the range or having more checks. Like, If I and j are equal, then we will definitely not ever get... Okay. So we did this wrong. We don't want to add that. We can see, obviously, these numbers, they're too large. So instead, we'll add just p, which is the thing that we actually want to add up together. And that did take slightly longer to run that time. So I'm guessing, this is a guess, that these are all 4-digit numbers, and we're going way too high with this upper limit here. But let's find out what we get. Because it kind of looks like we may have gotten the right answer. We just calculated. Like, we may have gotten the right answer if we'd done this instead of the wrong thing. So... and it honestly should have been obvious that this number way too big. I was explaining, so we're just going through this wide range. It's wider than it needs to be. I'm certain of that now. Yeah, so I bet we can cut this down by at least that much and get the exact same correct answer and have it be the correct answer. So let's check. That is the correct answer. So I cut down the range from 2 to 10,000 to 2 to 1,000, and I'm willing to bet that now this runs in a matter of seconds instead of taking over a minute. Yep, there we go. But it got the wrong answer. So that's very interesting. Let's see, which number are we missing? We're missing the 6952. So... cool. What if we just make... let's just make the outer one the 10,000 again and have this be 1,000 and see if that gives us the correct answer. Okay, so now we're back to the correct answer, and now we're running in 6 seconds instead of multiple minutes. Right, that's 4, 5... yeah. 4, 5, 2, 2, 8. 4, 5, 2, 2, 8. Okay, so... is this a little more than it needs to be? Almost certainly. Like, I really don't believe that we need to go all the way up to 10,000, and I don't believe that we need to go all the way up to 1,000. But without doing a little bit more experimentation, I'm not certain of how to make that a little bit more accurate. I think this is a very good... I think this is a decent solution for the problem in front of us. If we wanted to change the parameters here, it wouldn't be quite so fast. Obviously, I'm doing a double for loop. Technically a triple, but I'm not counting this one because, like, it's only going to loop through 10 times. It's not a big deal. Or actually, not even 10 times. It's going to loop through 9 times. So even doing that, like, for all 9-digit answers, it's not going to take very long. So yeah, probably not the most efficient way of doing this, but it does work, and I'm going to call it there for today. I'll see you in the next one.